Okay, so today we will discuss about uh, how the classes and objects are created. So in till my last class I have discussed that we will be in object oriented programming we will be solving the problem based on some collection of objects, and the objects are similar type of objects are collected in a class, or we can create a class and we can create objects from that. And there are different characteristics of object oriented programming, like the encapsulation, inheritance, polymorphism, etc. So we'll be coming all these features one by one. But for that, the very basic thing is that we need to know how the class and object concepts are created and how they are involved. Okay. So So the most important feature of C++ is the class. So the class is something similar to the idea of structure that is used in C. So we can also say the class is an extension idea of structure used in C. So in structures we have seen that within structure we can have multiple data types. So structure provides us the method of packing together data of different types. That means within a structure we can have strings, we can have characters, we can have integers, floats, etc. So it's kind of different than the arrays, because the arrays are the collection of similar type of elements, but in structure you can collect various different data types. Okay, so it is, you can say it is more more to the user defined data type. That is, user is specifying the structure data type and user is specifying the template, and which is more real, means more closer to the real world. That is, sometimes we create a structure for student or structure for a person. Okay, and say a structure for a student may have name, age, roll number. So name is a string type string, age is age and roll number is integers. If we want to store some marks, we need to store it in float variables. Okay, so to represent a particular student you need to store different types of data related to that student. So these different types of data, they belongs to different data types. So in structure we can collect different data types. It provides us a template, and then we will be creating different structure elements from that template. What are the structure elements? Say for example, say I'm providing you one blank form to fill up. Okay, so in this form, I have asked to fill up different data of you, like your name, role, age, your city, your hobbies, okay, your address, etc., phone number, okay, different things. And I have created one template. Template means that blank form is a template. I have created a single form for that. And after that, what we are doing, I am distributing this template to the class. I'm giving each one template to each one student. And then I am asking you to fill up the details. So once you fill up the details, so the data differs from one person to one student to another student. So when I get back all these forms previously it was same. When it was given, the template was same for everybody. But whenever we are storing some data in that, it becomes different from one person to another person, from one student to another student. So every student is following the same structure, same template, but we are creating difference by the data that we have stored. So these are known as the structure variables. They are known as the elements, structure elements. Okay. So once the structure type has been defined, we can create any number of variables or any number of structure elements which will follow the similar template that we have defined. So it is some means it is similar to the built-in data type declaration. Okay, like we define integer a, b, c, d, e, 5 integers or 6 integers we have declared. So similar to that, if we declare struct A1, B1, C1, D1 like this. So those are same as the integer variables. Like these are structure variables. So this is I have taken a very small example of a structure. It starts with the keyword structure, struct, and it declares the student with a new data type that can hold these three fields: the name is a character array, and integer, and integer role, and float marks. Okay, so these fields are known as the structure member or structure variables, and then we are creating one student. We are creating one variable. So struct student A. So A is a variable of type student, and it has three variables as defined in the template. So first variable is this name. I'm copying this name to this, and the roll number, I'm storing the roll number 12 into this a dot roll. So this dot operator along with the variable name is used. Okay, so member variables, this data member is accessed actually with the variable name and dot operator. So I'm storing 12 here for the roles, and for the marks I'm storing 85.5. So all these three variables I have initialized with some values. Similarly, if I create one more student, that is struct student B, and if I store some values to B, that will be a different set, totally different set. Okay, so this is how we can store, we can create structure elements, and we can store data in different fields by using the variable name and the dot operator. So there are some difference between structure and classes. So C has some facility of using structure, and also it is having some kind of limitations of using structure. So standard C does not allow the struct data type to be treated like built-in types. So this particular thing, that is, whenever we want to create any data type, whenever we want to create some user defined data type, our aim should be to use it as we use the built-in data types. So whenever we create built-in data types like integers or floats, okay, we can add them, we can subtract them, or we can do some modifications, we can do some processing with them. So what we will want to do with the user defined data types, we want to try, want it to do the same thing with the user defined data types. So for this, we need to do some extensions. Okay, so in structure, whenever we create this structure template and then the structure elements, so we can we can easily assign values with c1 dot x, c1 dot y, or c2 dot x, c2 dot y. Directly we can call them and we can assign the values. Okay, but if we want to add these two complex numbers like C3 equals to C1 plus C2, so this is illegal in C. This cannot be done in C. So this is one disadvantage. Another disadvantage is C structure do not permit data hiding. This is another disadvantage. That is, in this particular structure, if we want to access this x variable of C2, we can directly access this thing with C2 dot x. We can directly print or directly store values C2 dot x or C3 dot y or C3 dot x. Okay. So the structure members, they can be directly accessed by the structure variables by any function and from anywhere in the program. So structure members are accessible. So one of the feature of C++ or object-oriented programming is to hide the data. We need to protect the data, and we need to give limited access to the data by the functions that only can access the data. That's why we have created the objects. Okay, so structures, they do not provide permit data hiding. You can access these variables C1, C2, C3, or these x and y variables anytime from anywhere. Okay, so this is another disadvantage. And so we have extended the structure, the features of structures, all the features of structures are we are keeping, and also we have expanded the capabilities so that The user defined data types can be as close as possible to the built-in data types. That is, whatever we will be defining as user, we will be defining our own data type, and that can be used for storing data like we store data in built-in data types, for accessing data, for manipulation, or like we do addition or subtraction or any operation with these built-in data types. The same type of things can be done with the user defined data type. That is one thing, okay, that we want to do. And inheritance is supported by C++, which is not supported by C. Okay, so in C, in structures, we can see only we can store the variables. We cannot store any functions. Okay, but in classes, we can store variables as well as functions as members. Okay, so there are two things, two access specifiers that are known as private and public. Okay, so I'm coming to these two things, private and public. So we can name the members, we can divide all the data members within a class as private or as public. Okay, so what are the significance of them? I am coming to this thing. For right now, I am skipping this part, what is private and public. Then coming to the next point, in C++, the structure names are standalone and they can be used like any other type names. Okay, like we need no need to write down this struct keyword. We can delete that struct keyword, and in directly we can use the student A. Okay, so normally we used to like the means write the built-in data type like int A. Similarly, we can write student A, student B. Okay, so same type of declaration is allowed. Okay, and C++, they it incorporates all these extensions. Okay, in another data type that is known as the class. So let us see how the class is means declared. Okay, so class is a way of binding data and its associated functions together. Okay, so we will be binding data and the functions that can operate on the data. So this is a very basic fact of creating classes or creating objects. Okay, so we can, there are two parts. There are two parts for specifying a class. First is the class declaration part, and next part is class function definition. So I think you remember the structure that I have shown for a standard C++ program. There are some parts. First one is header file inclusion. Next is main function definition, and next is class declaration, then main function definition, and the member function definition. So these two parts were left that time. So after defining, after including all the header files, then you need to declare the class, and after that you need to define all the functions, and then you can call those functions from main. Okay, so I am today I'll show you how step by step these things we need to do, and at the end I'll be assembling all the parts, and I'll be showing you one program with the class and objects. Okay, so first part is class declaration. So to use the classes in the program, we need to first declare it. So this is the blue one is the syntax for class declaration. So all the class declaration, they will be starting with this keyword class and space, then class name. The class name may be anything. Okay, so you try to provide a class name that is having some meaningful class names, and try to avoid different keywords as class names. Okay, that is a standard mistake we used to do. Like we normally write down class 1, class 2 like this. Don't use that time. Try to use some real names. Okay. Okay, next is the classes. The declaration starts with these opening braces, ends with these closing braces, and always you put a semicolon after the class declaration. So this semicolon, this signifies the termination of class declaration. Okay, next within the class, we all know that some portion is data and some portion is function. Okay, so the data are known as the variable, so the data are known as data members. So we will be declaring some variables, we'll be declaring some functions. So this data is known as data members and the functions are known as member functions. Okay, so you can see there is a word called private and there is a word called public. Okay, now coming to the significance of this private and public. So you remember that we actually, the objective of creation of any class or any object is to provide the data hiding facility, is to encapsulate the data. Okay, so this private and public, dividing all the variables and functions in these two parts, these are known as access specifiers, and specifying the access of each variable, each data member and each member function is necessary in class declaration. Why we are specifying them? To create the data hiding facility, that is the basic of any object oriented programming. How we can do that? If we write down something within the private, that means inside private, if we write down something, this cannot be accessed outside this class. Means from main we cannot call the functions here, or from main we cannot call these variables. So how this portion can be accessed? By the functions that are written here in the public section. So we have divided the data and functions into two different parts. We have kept private, which is not accessed from outside the class, and some portion as public, which can be accessed outside the class. Okay, and this particular private section can be accessed via the functions declared here in the public section. So this is how we are creating the data hiding. We are hiding the data in some part of data that is essential in the private with the private access specifier. Okay, so let us discuss in a bit detailed manner. So I have discussed these things. Okay, so the binding of data and functions together into a single class variable is referred to as encapsulation, that we all know. Okay, so this is how the class is declared. This is an example. So class student, I have given this student as a class name, and then opening braces, closing braces. Private, in private I am writing the two data members, int age and int role. Okay, and in the public section I am defining the functions. So you can also define some functions in the private section. Okay, but for simplicity I am keeping the data as private and the functions as public. So these functions we can call from main. Okay, and these functions only can access this data. So here uh, the class student can be visually seen like this. So this is the class student and the data part is there. So this portion is the data. Okay, and these are two functions. So these functions only can access the data. They cannot be accessed directly from outside the class. It cannot be accessed directly. Okay, and public and private, they are known as access specifiers, and private members can be accessed only within the class by the public members, and public members can be accessed from outside the class. Okay, and the definition of this function, how to define this function. Okay, there are some certain syntax of defining the member functions. I am coming to this thing next. Okay, so next is creating the objects. So once you declare the class, next you can create some objects. Okay, so object creation is this. So student X, student XYZ, student X, student Y, student Z. Okay, anything, any declaration you can do. So that means the syntax is class name space object. So this is fine. Next is, once you create the object, you want to access this, data members or member functions. Okay, so first let us understand the memory allocation of the objects. That is, when any object is created, how the memory is allocated. Okay, so whenever say any object is created, say X, Y, Z. Okay, for student class, these three objects we have created. So for each object, the functions that we have defined, the two functions here we have defined, display and get data. These two functions are common for all of them. Okay, only one copy of the function is created in the memory. But for x, y, and z, for every object, this role and age will be created. For every object, this role and age will be memory will be allocated for role and age for every object separately. Okay.
I'm like X dot roll, Y dot roll, like that.
Now I'm coming that dot operator. Why we are calling them with dot operator? Just after this I am talking. Okay. So yes, you are correct that x dot roll, x dot, whenever we write down x dot roll, that means we are accessing the this particular role variable of this object x. Okay, x dot roll, x dot age. Okay, my point is, whenever the objects are created, separate memory is allocated for the data members. Okay, separate memory is allocated for the data members. For x, for y, for z, I have created three objects here. Okay, and we need to initialize them by our own. Okay, we need to provide values there. We need to provide some values there. Okay, and a single space is allocated for the display function here, display and get data. Only a single copy of display and get data is created for all the objects. Okay, this is not separate, this is not created separate, so this is common for all the objects, and this is every object will be having a separate data set. Okay, now to access them, we can access with the object name and dot operator. Okay, so this is the memory allocation. Okay, so memory space for object is allocated when they are declared, not when the class is specified. Okay, why this is so? Because whenever we declare the object, every object is allocated, means it is allocated a separate memory for the data members. Okay, and now if you initialize them, the object gets differentiated. So that was the idea. This whenever we thought of objects of fruit class, that is orange, apple and banana. So what we actually what makes them different, like if we store the value of shape or number of seeds, shape and seeds, this may be 6, this may be orange is some kind of round, and then apple is totally different shape. Okay, sorry, seeds are 6 and it is round, and apple may be 4 seeds or 5 seeds, it is not round, it is of heart shape. Okay, and the banana is having no seeds, and it is like a straight line shape. Okay, so these are different, all of them are having the variables shape and seeds. Okay, so my point is here, whenever we create object, we'll be creating separate memory for the data members. Okay, and these functions are common. Okay, member functions, they are created and placed in the memory space, they are common for every object. Okay, and since all the objects belonging to that class use the same member function, no separate memory is allocated for the member functions. Okay, when the objects are created, this is common, only one definition. Whenever object wants to access them, they can access with x.display or x.get data. Okay, and only space for member variables are allocated separately for each object. So this you always remember. Okay, and whenever we want to access the class member, that one of you are telling, yes, we'll be using this dot operator. Okay, using this dot operator, we can access the class member. So we can access the class member in this syntax, that is the object name dot the function name. Okay, and the arguments. if there is any. We can just access them. We can call the function in that manner. Okay. So if we want to now means now our aim is to use the access the role and age, that is the data member. Okay. So if we write down this one, x dot age is 20. So this is illegal actually. You cannot do this thing. So though x is an object, okay, but you cannot do it because this age is defined inside the class and inside the private section. Okay. So age can be accessed by the functions, member functions that are written in the public section only. You cannot directly access this one. Okay. So whenever you access, whenever you write down this one, x.display, that display will check this function x, this declaration, it will check which object is under consideration, x is under consideration. Then it will access the variables x.age and x.role by this display function. Then it can access. Okay. So it maintains the rule of access specifiers. Okay. So let me discuss it with one more example. Say there is a class, say class item, say int x, int y, and public section int z. Okay. So this is the definition. So if you are not writing anything, by default all the members are private. Okay, this is one more rule. Means if you are not writing private explicitly, defining them as private, okay, so it will be used as the private. And one more thing is that we will be writing here private or public, then we need to put this colon, and in the next line we'll keep some space, some indentation, and then we will be declaring the variables. This also you keep in mind. Okay. So now if I do this thing, say item I1. Okay. Now I want to I1 I have declared. So now I want to access I1 dot x is equal to say 100, or I1 dot y is equal to 10. So this will give you error. Okay. We cannot from this is within main. Sorry. Sorry. This is within main. Okay. So main is a function outside of this class, and we want to access, we have created this object and we want to access these variables of this object, data members of this object. So you cannot directly do that because they are in the private section. But you can always do this one because Z is in the public section. Okay, so this is correct. This will not give you any error. So my point is to access any data, access any data member through any object or a object name, you need to check whether it is defined in the public section, declared in the public section, or in the private section. Okay, so that's why normally the data members are written in the private section, because our aim is to protect the data from accidental modification. That's why they are all written in the private section and the functions are written in the public section. So these functions, some functions are written in the public section so that we can access these data members through these functions. So this public section, whatever you are writing, you can directly call them. If there is any function called display in the public section, you can directly call it I1 is equal to display. So now one question may come, how to define the member functions so that we can access the data members, both the private and public data members, or how we need to solve a problem. Okay, so next I'm coming to that point. So we can define the member functions by two types. There are two process. One is outside the class and another is inside the class. You can choose any of them. Okay. So the syntax for uh, defining the member function outside the class is this. First, we need to write down the return type, then the class name, and this is the scope resolution operator. So scope resolution operator I have discussed in my last class, that it defines the scope. Okay, so here there is a massive use of scope resolution operator with the class name and the function name and normal argument list. Okay, so this is the syntax, and within that you need to write down the function body. Okay, so return type, function name and argument list was the normal function declaration in C, function definition in C. The same definition is there in C++, but you need to write down which class this function belongs to. So this scope resolution says that this display function or this get data function, it belongs to class student. It may be there in your program, it may happen that you are having one class called student and maybe one class called say teacher. Okay, and both the student and teacher is having a function, similar function called display. Okay, so that time whenever you are defining the display for student or whenever you are defining the display for the teacher, you need to make some difference. So that difference can be done, or we can signify in from which scope or from which class this function is coming. This function belongs to which class. You can define the scope with the class name and scope resolution operator. Okay, so this is the syntax and this is the example of the display function. Void is the return type of this display function. This is the class name student, scope resolution, and the function name, and it was not passing any argument, so it is blank. Okay, next is this one. So cout, with these two couts I am just printing the value of age and roll. Okay, normal age and roll I am printing. Okay, next is how to define them inside. So inside means you can just replace the declaration of the function by the definition. So here is how we can write down the class definition as well as the member function we can define inside the class. So it totally depend on you that if you are comfortable with defining them outside, you just need to mention, just need to maintain the proper syntax like writing the class name, the scope resolution, return type, etc. And if you want to define them inside the class, just normally you just replace the declaration with this definition. Definition always contains these braces, opening and closing braces, and no semicolon after it, and you will be just writing the statements here. So this is display and this is get data. So this is the whole class definition along with the member function definitions. Okay, in this particular example that we have considered two data members and two member functions. Okay, this is the return type, the function name, and normal function definition. So display is actually displaying these two age and role, and get data is asking to enter age and role from the user, from the keyboard. Okay, up to this. Okay, no query or no confusion. Is there any confusion? Please tell me. Okay, next is the main. Okay, so if we declare the class, if we define the class, it's fine. Now we need to create some objects and we need to display or take the values for those objects and need to display them. Okay, so that we can do inside main. Okay, so in main we are defining the objects, we are creating the objects, we know how to create the objects, that is class name and object name. Okay, so I have created one student X. Okay, so as I have already discussed, whenever you create some object that is X, if you have created, separate space is allocated for all the data members that you have defined. So only two data members were there, role and age. Okay, so whenever you call X dot get data, so whenever this X dot get data is called, control goes here, this get data function will be executed, and it will be asking you enter age and role. Okay. Now say you have entered age as 20 and role as 1. Okay. So this value 20 and 1, where it gets initialized? It gets initialized here. X dot, this is 20 and this is 1, because we are calling x dot display. Okay. The compiler always considers this x object. So even if you are not writing here x dot age or x dot role, it will consider the object which is calling the function. So if x is calling this get data function, that means x, this age means x dot age. This age means x dot age. If x is calling this get data, this role means x dot role. Okay. Now say if you have one more variable, one more object, say y, and one more variable z. Okay, so as per my definition, I told you that separate role and separate age. Memory is allocated for role and age for x1, x and y separately. Okay, so now if you write down this one, y dot display, sorry, y dot get data. Okay, so that time get data, the same get data will be called, same get data will be called, and that time age will be considered as the y dot age. Okay, not x dot age. That time age will be considered as the y dot age. Okay,
Ma'am,
clear? Huh.
want the header, ma'am, the part where you are like int main and the part where you are doing int main student X, ma'am, won't the heading be calling member functions and not defining member functions inside the class? On the next slide, ma'am, not the slide after this.
Huh. They are calling, yes, not
Okay, that
defining.
is
Sorry,
calling
sorry,
it. Okay, okay, thank you.
sorry. This is wrong. Sorry, this is calling the member function. Okay, I forget to clear it. Okay, this is wrong. This is not defining. We are just calling it. We are just calling it. Okay, so this int main, we are just calling these two functions. This is definition. These two are definition. In continuation to that, I have written this one. Okay, the main, this is int main, and we are calling them. Okay, so x dot get data means simply we are calling them. So you get my point now, what I am actually want to say. Whenever you create any object, separate memory is allocated for role and role and age for y also, for z also. Okay, but whenever you call any function, because only one copy of that function is there in the memory. Okay, no other copy is there, only one copy. Every object will be using the same copy, same display, same get data. But what means which age and which roll number to store the values, that depends on which object is calling the get data. If x is calling, if x dot get data, if x is calling, that means x dot age and x dot roll, this age and this role means x dot age and x dot role. Okay, that's why the scope is important. Okay, that's why the scope is also very important. Similarly, if y is calling this display, y is calling display, that time this age and role, this age and role, this will be replaced with y dot age and y dot role. It will not showing the others. So we need to specify the object name and the dot operator to make the display function understand that it is requesting the display function to display the value of y, object y, or it is requesting the get data function to take value for object x. Okay, get my point. Next is, this is one simple example. Yes, any confusion? Tell me. Okay, you understand na this example. So how to write down the program? So whatever, whenever you write down any C program, C++ program, you first enter all the include files. Then for some compilers, it ask you the namespace to include, and then the class declaration. As many as class if you want to use in your program, you can declare them. Then either you can define the member functions outside the class, or you can define inside. Okay, so in the later lectures we'll be checking out that sometimes we'll be defining them inside, sometimes we'll be defining them outside, and then we need to create objects within main and call the member functions. Okay, so this particular program is a very simple program I have taken just to make you understand how objects are created, how data is taken to the object, and how it is displayed. Okay, but we can do different other programs. The basic thing you need to understand, you understood this thing now, how the memory is allocated and how the member functions are accessed separately, separate member functions can be accessed. You understand this thing now? If anybody is having any confusion, you can tell me.
Ma'am, ma'am, no matter whether the member variables are private, are made private or public, the member functions can always access them, right?
Member functions can access them, but they need to be declared in public here. If you define the member function here in the private section, then those member function you cannot call them by using this object and dot operator from outside. Means if you make this thing, this get data here, if you write down this particular display here, okay, that means at the public private section, that time if you call it like x dot display, it will give you some error, it cannot be accessed. Functions Functions are normally written in the public section so that they can access all the data members which are written in the private section. Okay.
Acha.
Okay. If you write down, there are private data members. Private member functions are there. You can define the private member function. That time we will be using some technique that is nesting of functions. Okay. We can call one function from another. Okay. There must be some function in the public section which will call that function, and that function can access this data. This will be the procedure then. Okay. This is also possible. But to access any private data member, you need a public function, because public functions can only be called from the class. Okay. Clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, so let me show you some examples. Okay, basic small examples. First example I have created here, I have not used any function, member function here. I have just used some public variables. You can say public data members. Just I have used 3 of them, and I am creating this car object, and I am doing this thing. Car object dot one dot brand BMW, etc., etc., etc. Okay. So I'm just creating one object, I'm creating second object two, and I'm printing their values. I'm just printing their values. So this will work fine. Okay, because all of them are in public section. So anything written in the public, this can be accessed from outside the main. Okay, means from outside the class, it can be accessed from main, any function, main or any function. Okay, so you can directly call them, they can be accessed. But if you make them as private, you cannot call them, these will give some error. Okay, so let us see. I have written here 3 programs. Okay, let me share another screen. I'm coming out of this screen. Yeah. Okay, so I have written a program for which will take the height, length, and breadth of a particular box, and it will be giving calculating the volume of that box. Okay, I'll be creating 2 objects and I'll be passing some values, and all the 3 programs will be giving you same output, but different scenarios, different type of writing the program, different process that I am going to show you. First is the class I have declared here, and then the class box, and in the public section you can see I have declared 3 variables. In main I have created one variable box, one object box 1, another object box 2, and defined one variable called volume stored 00, and then for box 1 I am taking the values box 1 dot height, box 1 dot length, box 1 dot breadth. So this will work fine. If we compile it, it will work fine. Okay, because all this length, breadth and height, all the variables data members are written in the public section. So from main we can access them directly. So for box 1 I have stored the values directly. For box 2 also I have stored all these values, and then for volume I have just calculated box 1 dot height and this box 1 dot length. For box 1 I have calculated the volume, and for box 2 also I have calculated the volume. Okay, so this is simple. And next, if I compile it, it is just showing the output. Yes, volume of box 1 and box 2. Okay, now if I say, if I made this as private, these two, and this is as public. Now you see what difference it will give. It will give some error telling that, yes, it will give some error. Check the errors. Okay, it is giving some error. It is saying the length is private within this context. So box 1 dot length, we cannot do this one. Okay, so here length and breadth. Length and breadth is private. So we cannot do this thing. These two thing is wrong. This two is wrong. This two is wrong. Okay. Next, for this one also, sorry, length and breadth. This two is wrong. Similarly, for this one, this two is wrong, because height is height. Okay, and this one also not take length, box 1 dot length, box 2, box 1 dot breadth, they cannot access. So this is wrong. So that's why it is giving so many errors, all the errors for this length and for this breadth. Wherever we have tried to access length and breadth, whether we want to store the values or whether we want to access the value, everywhere it will be giving the error. Okay. Next program, the same program. You see what difference I have made here. I have changed this thing. I have changed the volume. Previously volume were declared outside here. Sorry, let me make the change. So yeah, previously we have calculated the volume where the volume is declared inside main. Okay, now I am making this volume also as a data member. Okay, so volume I have maintained written here as a data member. Public section itself I have written, and then I am writing this volume as this height, length and breadth. Okay, and it is returning this volume. Okay, so this is, sorry, so this is the definition of this function volume. Okay, so in this function volume, what we are doing actually, we are calling this function, then we are getting this height, length and breadth multiplied and stored, and then we are returning this thing. Okay, so previously we are doing or the calculation for volume for box 1 and box 2 separately. We need to write down this formula separately. Okay, this one and this formula separately. But now my aim is to create only one function which can be used for any object. Okay, so the second one, what I have done, I have created one function, and volume, this one I have kept here inside the class declaration, and just see the difference. Box 1, box 2. Next is this height, length and breadth. I have stored them. Height, length, this one is not required, but you can always store it. This one is not required. Let it be. So next is this one. Box 2, box. Please switch off your microphone. Okay, so next is for box 1, I am taking height, length and breadth. Box 2 also I am taking height, length and breadth, like we have done it previously, because they are public, so we can directly initialize the values. Okay, now here see volume of box 1. Here I'm just calling box1 dot volume. Box1 dot volume, and for box2 I'm calling box2 dot volume. Okay. So the single function is called for both the objects. So whenever we called box1 dot volume, the control goes here. So that time this volume becomes box1 dot volume, box1 dot height, box1 dot length, box1 dot breadth. So it will calculating the volume for box1, as we have mentioned box1 with dot operator. And whenever you call this one with box2 and dot operator, it will calculate the value for box2. So if I run it, you just see with the same volume function I am calling, but they are giving two different values. Okay, box1 and box2. So both are giving me same result. Okay, for this one and for the previous one, both are giving me same results because the values are same. I am providing 5, 6 and 7, 5, 10, 11 and 12. Okay, so this is same. So my point is we can have single function. We can have a single function, and if we write down in this way, for box1 we are calling this volume, and box2 we are calling this volume function. So whenever you call any function, the compiler checks with which object it is called. With reference to that object, all the data members will be considered. So box1 is calling this volume function. That's why height, length and breadth is considered for box1, that we have entered 5, 6 and 7. Okay. Similarly, for box 2, it is considering 10, 12 and 13. Okay. Next comes the third one. So in the third one, what I have made all this length, breadth, height and volume in the private section. I have introduced two functions. One function was same, that volume function was same. Okay. And this is one more function I have introduced, put data, to take the value for the length, height, length and breadth. Okay. And put input data, I have passed some values H, L and B. I have passed some values. Okay. So you see here, I have created two objects, box1 and box2. Fine. Then I am calling box1 dot put data. Okay. So whenever I calling box1 dot put data, this we are passing 5, 6 and 7. So this H is mapped, this 5 is mapped to H, this 6 is mapped to L, and the 7 is mapped to B. Okay. And height. So this height is what? Box1 dot height or box2 dot height? Box1 dot height, because we are calling box1 dot put data. Okay. So this height will be having value 5.0. This is 6.0. Box1 dot length, box1 dot breadth. Okay. Similarly, for box2, whenever we call box2 dot put data, all the data will be stored in the length, breadth and height corresponding to box2, and we are just displaying them with this volume, box1 dot volume and box2 dot volume. So you got my point, how we are accessing the objects, how we are accessing the data members for each objects. So the memory allocation, that thing you need to keep in mind, that whenever we create object, separate memory is allocated for the data members for every object, and single member function is created in the memory. And we need to do the single member, we need to call the single member function again and again by specifying the object name and the dot operator. That's all. Okay, so it will also give the same answer. I'm doing a single program with three different process. Okay, it is giving the same answer. So you understand this thing. Na? If you have any confusion, you tell me. Yes, you understand this thing, na?
Yes, ma'am.
Okay, so I'll not continue today up to this. Today up to this is okay. I have created the objects. I have created the class, declared the class, and then I have created the objects, and I have shown you how to store the values in the objects and how to retrieve them. We can have any function. That rules related to function like passing and returning values, etc., all are same, all remain same. Just you need to remember what portions you are writing in the private section and which portions you are writing in the public section. Okay, then we can solve some problems. So I have also included some problems here. You can see them. Okay, I'll be sharing the slides today. The whole slide I'll be sharing today. Okay, so the rest of the section I'll be discussed in the next class. Next, you have class on Wednesday. So we'll be discussing this thing on Wednesday. Okay. So if you have any query, you can ask me. I'm now I'm means I'm stopping here. So